In this video, we're going to sketch another exponential graph. In this particular graph, our base graph, without any additional add-ons, is the graph of y equals 10 to the power of x. Now, let's do this a bit of a slightly different way. Instead, let's take our knowledge that our graph is already looking like this and start to transform the graph based off its transformations. So what happens to this 10 to the power of x first? Well, it gets multiplied by -3. So we already know that there's going to be a reflection in the x-axis, which means that our graph, horizontal asymptote, gets reflected downwards and is also dilated by a factor of 3, so it's going to look a bit steeper, like so. The next thing that happens to it is that we add 6, which means that the entirety of the graph, including the asymptote, gets shifted up by 6 units. So our horizontal asymptote here is no longer at 0, it's at y equals 6, and our graph has moved up like so as well. Now, I know we have to draw a horizontal line as a dotted line, and now it's a dotted line. So now that we have an idea of what features we have, we can start docking things in straight away. So we've got a y-intercept, a y-asymptote at y equals 6. We just need to find out our y-intercept and our x-intercept. Let's go ahead and find our y-intercept first. Our y-intercept is when x equals 0, which is the same as f of 0 because we're using function notation. 10 to the power 0 is 1. -3 plus 6 is equal to 3. So our first piece of information here is 0, 3. There it is. And we also need to find our x-intercept as well. That's when y equals 0. So we have f of x equals 0. -3 times 10 to the power of x equals 2. Plus 6 equals 0. -3 times 10 to the power of x is equal to -6. 10 to the power of x is equal to 2 because we divide by -3. And x will be equal to log base 10 of 2. Now log base 10 of 2, that would be somewhere between 0 and 1. Well, we can either find our extra points or we can just guesstimate. What we might do is find what the y value is at x equals 0.5 or 1/2. Or we can find out what the value is when x is equal to 1. I'll do that first. So -3 times 10 to the power of 1 is just 1. That's -30 plus 6, which gives us -24. So that's all the way down here at x equals 1. Our y value is somewhere all the way down here. So I'm going to find out what the y value is at an x value of 0.5, well, it's the same as 1/2. Well, 10 to the power of 1/2 is the square root. So what's the square root of 10? That's super close to the square root of 9, which is equal to 3. So -3 times 3 is -9. -9 plus 6 is -3. So at 0.5, we're still somewhere down about here. That's approximately equal to. Sorry, maybe I should be a bit more clear here. We've got -3 times roughly 3 That's negative 9 plus 6, which is roughly equal to negative 3. So at a y value of 0.5, our y value is around negative 3, which means that our x-intercept must pass between these 2 points here. Now that we've got our x-intercept and our y-intercept, all we need to do is just label. Our domain, again, is going all the way to the left and all the way to the right. That's going from negative infinity to positive infinity, which is the same as all real numbers. Now, our lowest value now is starting from negative infinity, and it goes all the way up until a y value of 6, but not including 6. Remember to go from the lowest value to the highest value. Okay? Okay. Don't forget to pause, rewind, and replay if you want to rewatch.